Hello and welcome to today's webinar. My name is Jonathan Tro and I'm a curator here at SRA. And today I'll be demonstrating how to access our new data format, SRA aligned reads, and some of the features and benefits that offers, as well as how to use Amazon's Athena resource to search SRA metadata in the cloud and help narrow down your search to runs that contain data of interest before you really ever need to download or dump anything. So just a quick overview, we'll start out with a little bit of background, sort of SRA in the cloud, why. Then we'll move on to Amazon Web Services, the Registry of Open Data. I'll explain what SRA aligned read format is, and I'll show how to get started on Athena, and then we'll move into some example workflows in Athena. And finally, I'll show how to access the aligned read format on the command line, and then we'll move on to question and answers. So SRA in the cloud, why have it? You can do some of this searching and access from NCBI directly. Why have it in the cloud? Well, SRA data archive format is now over 18 petabytes, which is great. It's a lot of data and there's a lot of interesting stuff there, but it's a lot of data that can be really hard to search, which is not so great because when there's that much data, you need some way to narrow it down to what you actually care about. And so in this regard, Athena offers a number of advantages. It provides new and robust search capabilities to SRA cloud customers on AWS. We also have some search features available on BigQuery for GCP users. But what Athena really allows us to do is facilitate fast search using parallel execution of queries with multiple methods of access. So what I'll be showing today is mostly the browser-based query builder, which I think is what most new users will want to start with. But they also have a collection of client libraries that can be used within your workflow, or you can just access it using the command line interface. So you get fast search with a lot of ways to access it depending on what your personal workflow is. And this is a benefit to NCBI is that it's a great foundation for us to continue updating this and changing things and to be able to quickly respond to user feedback. So I'll have an address you can write into with suggestions at the end of the presentation, and we really need that feedback from people who are using it to guide future development to figure out what we want to do next and what would be the best service to our users. And finally, it can be pretty easy to get started with SQL. There's a little bit of a learning curve if you've never used it before, but it gives you a lot of power with drilling down into the data to find exactly what it is you want. And to that, we'll go to our first poll, and we just want to gauge for attendees who are online now, how familiar are you with SQL? Ranging from I've never heard of it to you're a pro and use it all the time. This will sort of help us get a gauge on that. So we've got a split there. I'm not going to do an in-depth SQL tutorial today. I'll cover just a little bit of basic terminology for beginners, but we do have a few links here if you want to explore that more and you're new to it. So I've got a couple links to Athena's.
Okay, let me go ahead and stop sharing the poll. Okay, now you're back in. Okay.
So we've got a few links here to Amazon's own documentation, and they've got a basic rundown of the implementation there in Athena. In addition to this, there are numerous online tutorials, both free and paid, which can give you a basic introduction to working with SQL. Amazon's Registry of Open Data is a listing of publicly available data sets, and it's a way to kind of search and find data that's been made available for general use. And SRA has had a set of COVID-focused data up there since July. And the new aligned read data format that I'm going to talk about today is also available there now. This brings a number of benefits. So it allows you to access a large volume of COVID-19 related raw read data at full cloud speeds and at no cost to you. In addition, it lets you analyze this data in addition to your own cloud hosted data sets. You can easily combine these. And if you want to set up a pipeline there in the cloud to combine both data sets, that's pretty easy to do and have all of your data files in a single location, which I think can be a really easier way to deal with some of this data. I mentioned that our new data format are the SRA aligned reads. What are those? So it's a compressed data format. It is in some ways similar to existing SRA data in that it can be used with the SRA toolkit to dump data formats, but it also has some new data in it as well that's not available anywhere else. So briefly, contigs were created from runs in SRA that were found to contain coronavirus k-mers by our taxonomy analysis tool, and that uses a k-mer approach to identify the origin of reads in a run. And any run that had at least 100 hits to coronaviridae or child taxa was then selected for analysis. And a few other selection criteria were applied to those, like minimum read length and sequencing platform, and contigs were created from that resulting set of runs via guided assembly to the SARS-CoV-2 RefSeq genomic sequence. And if contigs were successfully created, then those reads were mapped back to the contigs and coverage was calculated. And so these SRA-aligned read objects, they contain the contigs that were constructed. They also contain the raw reads that were used to construct those contigs, and you can dump that data kind of however you want with the toolkit. So you have access to the individual raw reads or the contigs individually. So if you have the SRA-aligned read object, you can use FastQ dump from the toolkit to dump FastQ just as you would with any normal SRA run. But if what you really care about are those FastA contigs, you can just dump those and get those in fast format as well. And one thing I'll note is that a number of these biosamples are not present in GenBank. So these represent a brand new sequence that's really only available here. And if what you care about are both the contigs and the reads, you can see the reads mapped onto the contigs by using the toolkit to dump in SAM format. So you can see where those align to the individual contigs. In addition, these aligned reads are a smaller size than our standard SRA format. One reason for that is that they don't have quality scores. So this makes them quite a bit smaller to download, a lot smaller to work with. So dumps on these objects are much faster. And so it's just about getting you into the data and working with it as quickly as possible. Now here's going to be our second poll, questioning how familiar you are with Athena. And so this is, as I mentioned, our first release of searching of metadata in Athena. So I'll be curious to see how many of our users are familiar with it and have used it before. And so the aligned read objects, as I'm about to show, we've set up metadata in Athena that lets you do specific searches on submitted and calculated metadata to help you find the ones, the specific contigs or reads that are of most interest to you. So it looks like the majority of people here haven't used it before. So that's great. We'll walk through an example of how to get it set up if it's your first time. And so it's actually pretty easy to get started with. All right. So we have these new aligned read objects with new data, but we also have new metadata that you can query using Athena. So since a lot of people here have never used it, what is Athena? It's a query service for S3 data analysis, and it allows you to directly query data that's stored in Amazon S3 using standard SQL syntax. And this means there's no need to manually transform the data for querying. You don't have to like download some XML file from us and then transform it into some pseudo database and try to query it. Amazon has tools that kind of does this for you automatically, and it makes it really easy to kind of just be up and running in a few minutes. And I'll show an example of that during setup. And the data we've uploaded there allows you to use Athena to search taxonomy, BLAST, and annotation results for these aligned read contigs. So after the contigs were created for SRA aligned reads, the taxonomy was assessed via two methods. The first is that contigs were assessed using our SARS-CoV-2 detection tool, which uses a similar K-mer-based approach to our taxonomy analysis tool. And the second is that the contigs were checked via megablast against the nucleotide blast database. And all of these results are available for querying in Athena, which just allows you to focus on the runs or reads of interest to you before ever downloading the data. And you can query these calculated metadata results in combination with the user submitted metadata, such as sample information, to get an even more focused result. So there are two separate buckets of data that are available for querying in Athena that I'm going to talk about here today, and I've got them in two columns here to kind of try to make it clear that there's two separate sets, and they can be queried together, and you can even import them to the same database in Athena, but I'm going to talk about them separately just for conceptual reasons. The first is this aligned read metadata. This is calculated metadata on these contigs. And so here we've got individual data on the contigs like coverage and taxonomy ID and their contig length. There's also taxonomic content analysis of the contigs, so you can search for records based on K-mer hits to your taxonomy level of interest, for instance. And there's also BLAST results here. So you can search for records based on a hit to your accession of interest or the hit length or the percent identity or the bit score, for instance. And the S3 bucket address for that set of metadata is here. You don't need to memorize that or anything. It's also present in our documentation. It's just sort of there for the record. In addition to this, we have available total SRA metadata. And this includes user-submitted sample information for everything in SRA, so where the geographic location where the sample was collected or the collection technique. This includes sequencing and library information. Is it single-end or paired in? What was the sequencing platform? As well as taxonomic content analysis for everything in SRA. So again, you can search based on k-mer hits to your species of interest, or if you want to look at a metagenomic sample and get a look at what's in there by our analysis before downloading it yourself, you can do that too and just get a list of it. And this is the S3 address for that bucket, which again is just here for the record. And so these can be queried individually, but you can query them together to get a little bit more of a focused and filtered result. And I'll show an example of that later. Since we have some people who are not familiar with SQL, I'm going to do a very brief crash course on a couple of key terms, which will hopefully help you follow along with the basic queries. First is select. This is a command to extract data from a table. You're essentially telling the database what you want to get back in your answer. And so a lot of times you'll use select star or asterisk. This means it's a wildcard, give me everything. Or you might say select just the run accession. All I want are the run accessions back. From is the clause to specify which tables to extract from. So select the run accessions from the contig table, let's say. And where is the filter for that table? So select the run accessions from the contig table where coverage is greater than 100x. And then order by allows you to order the result by a specified column. So you might order by coverage descending, so you get the highest coverage first on down. So select the run accessions from the contig table where coverage is at least 100x, order by coverage. So we're gonna go into the actual Athena demo now, where I'll show basic setup, and then I'll show a few queries as well. And I'll begin with a basic query that can be an easy one to start with if you're new to SQL, and then I'll move on to a couple more complex queries that connect submitted sample metadata with calculated contig information. So when you start with Athena, you'll see this page. Depending on where you've logged into AWS, you might be on various different pages, but you can usually always go to this little services drop down and start typing, and it will autocomplete for whatever you're looking for. So here you can type Athena, or if you've recently visited, it'll show up over here, and you can even star it and put it in your favorites. But any of those you can click on, and it'll take you to the start page. Click the Get Started blue button, and you'll end up here on the query editor. And this is where you would actually type in queries. You wouldn't have queries already here like I do. And in fact, you wouldn't have databases or anything yet. And so what you would want to do is go to connect data source. And this is how we're going to point Athena at the data we actually want to query. For a lot of these pages, we're going to leave the settings on default, and I'll tell you when that's not the case. But we're going to start here. We're going to leave it on query data in Amazon S3 and AWS Glue data catalog. And click next. And here I'm going to leave it on setup crawler and AWS Glue to retrieve schema information automatically. The crawler is going to automatically scan the data source, the S3 bucket. It's going to identify the data formats and sort of infer the schema. So it's going to make a database for us out of this S3 bucket. If you want to do this manually, you can. You can import the tables manually and define all the columns and fields. This is more of a power user move. We wouldn't recommend this for anyone beginning or who doesn't have a really specific reason, because it's certainly more effort, and the Glue crawler will sort of do it for you automatically, which is what we're going to do here today. So I'm going to click the Connect to AWS Glue button. That opens up AWS Glue in a new tab. And here we need to give a name for our column, for our crawler rather, and I'm sort of call that whatever you want. Call mine Demo 2. We're going to leave this option on data stores and click Next. And here you definitely need to make a change. So we need to give it the path to our S3 bucket that we're hoping to query. So I have that saved over here. This is just the path to the aligned read metadata. I'm going to paste that there. Click Next. And here I'm going to say no for add another data store. If you wanted to, you could go back and add the total SRA metadata here as well. So if you click yes, it'll take you back and let you put in another S3 address, for instance. But I'm going to leave this as is and click Next. And we need to choose a role here. I'm using a personal account because I think this is probably what most people would be using when they were first starting out. And if that's the case, then you can just sort of create a role name here. It can be whatever you want. If you happen to be logging in through an institutional account where they are controlling all the roles and policies, you may need to choose an existing role. So you would select here and pick one from the drop-down of available options. But I'm going to go ahead and create one. I've used that one before. Demo 4 then. Demo 10. Certainly, I haven't done that many. Click next, and frequency, we're just going to have it run on demand. You don't need to do this every time you want to query Athena. This is an initial setup, and once we've imported it to a database, you can come back and query it whenever you need to. You would only need to run this again if we change something about the underlying structure, like added in a new table or something, and we would have communication about that. So I'm going to click next there. And finally, we need to select the database to import this to. If you have existing ones, you could select one of those from up here. I'm just going to create a new one, call it demo 10, create, and click next. And here you can look over all the information you've put in. If you want to go back and change it, you can. This looks okay to me though, so I'm going to click finish. And what this does is it creates a crawler for you, which is in this list. And if this is your first time, you just have one there. This is the one I just created. You can see it's never run before, but if you look at the other crawlers I've run in the past, you can see these usually take about 1 to 2 minutes to run, so not too long. And the scanning of this data is inexpensive. It should generally cost less than $1. And then to run it, after you've selected it here, you click Run Crawler, and it'll start running. In the interest of time, I'm not going to wait for a couple of minutes for this to finish. I'm going to go ahead and go back to my Athena window, and where I've already imported some databases, but you can see that demo 10, the database I just created, exists here. It doesn't have tables yet because that's still populating, but in a minute or two, it'll have those tables. But I'll start with an aligned reads table that I've imported previously. A couple of quick things I want to show. If you want to see which tables are available in this database, you can click this little down arrow and it'll show you over here on the left. And if you wanted to further look into the contents of like the blast in table, for instance, it shows you the different columns here. So like accession, the length, score, percent identity, etc. But it can usually be, it's often a little bit easier if you click on these 3 dots and click preview table. It'll just show you the first 10 rows of that table, so you can sort of see everything that's in it. And so you've got the run accession, this is the name of the contig, and then you've got information about the blast hit, the bit score, the length of the hit, percent identity, etc. So using that preview feature can be a good way to get a sense of what's in there. A couple other interface things I'm going to point out before going to the demo queries. One is that after you run a query, it shows you here how long it took and how much data was scanned. How much data is scanned is how you're charged in Athena, and they have the pricing on their website. It works out to $5 per terabyte. So all the queries I'm going to show today costs pennies, and I'll cover that more at the end. Also, if you want to save these results are saved to an S3 bucket for you, but if you want to download the results in CSV format, you can click this little button here and it'll just download it for you. If you have a big result set that you want to analyze offline or look out further, you can do that, and that shows up there. If you have a query that you think you'll want to run again in the future, you want to check back and see if new data is coming in for this query, you can, once you have it here in your query window, you can click Save As, give it a name and a description. I'm going to cancel here, but when you click Save there, it'll show up here under your saved queries. And you can see I have some here. If I just click on one of these, it will bring it up in my query window here. All right, if this is your very first time using Athena, one more thing you may need to do is go to this workgroup tab, and you'll need to have a workgroup with an S3 bucket associated with it, which is where your results will be stored. So if you already have a workgroup with an S3 bucket associated, you can select it here and click the switch workgroup button, and then it'll be active. If not, you can click create workgroup. You can give it a name. You can enter the address of your S3 bucket and click create down here, and it'll show up in this list, and you can switch to it. So I'll show an example of a query now. So this is the first query. I'm going to go ahead and run this. This is a pretty basic one. We're just querying the contigs table. And this has a list of all the contigs that have been constructed for the SRA aligned read objects. And so I'm selecting everything from the contigs table where the tax ID is for SARS-CoV-2, and the coverage is greater than 100x, and the length is greater than 20,000. And you can see my results down here. So this just gives you a list of all the contigs that might be of interest to you in this case. And if you're a beginner to SQL, this might be a simple one that you could use. You can toy with some of these options here. Instead of coverage, maybe you would want to look at hits or something else, just to get a sense of how you can change these queries to get the result you're actually interested in. And you can see it shows data scanned here was only 42 megs in this case. So I mean, this query costs less than a penny actually. But you can do some interesting stuff here, and I think if you combine submitted metadata with our calculated metadata, you get more interesting results. And so this is an example of that. Here I am querying both the total SRA submitted metadata and the BLAST results for the aligned reads. So I'm starting with a subquery where I'm selecting all of the running sessions from the BLAST results, where they got a BLAST result that had a tax ID of SARS-CoV-2. And then for all of those accessions, I'm going to the submitted metadata for those runs, and I'm getting the name of the country where the sample was collected, and also taking account of that country each time a country comes up, and I'm ordering by that count. And so what we see down here in our results are, you can see where, for all of these contigs, where were those samples actually collected. So you can see we have 1,700 from USA, 1,600 from Australia, and on down. And so if, for instance, you're interested in one specific region, like perhaps South Africa, you could drill down into that more carefully and look at the actual data underlying that. So here's one more example. If, for instance, you're interested in the South African data, I'm here querying the total SRA metadata table. I'm looking for samples that were collected in South Africa, and then I'm using all of the runs that returns, and I'm looking for the corresponding hits in the aligned reads BLAST table so any of those runs collected in South Africa, which ones had BLAST hits to SARS-CoV-2, and I'm looking at those and the maximum bit score. And so you get the maximum bit score over here, and you have the contigs listed over here, and we can see that there's a number of good hits from this run in particular. So if you wanted to go and search and get the data for this run, you can do that pretty easily. So I'm here bringing up a command line tool. Really, I'm just logged into a little EC2 instance here. This is really easy to get started with. If you have no experience with this, on our cloud YouTube channel, we have a little video that shows you how to start an EC2 instance and get the toolkit installed there. And it's like a little 6-minute video. It's very easy. And this is a free tier instance, so it doesn't cost a lot to get started on this. But once you have a run of interest that you want to look at the aligned reads for and the contigs, you plug the run accession into this S3 address, which no need to memorize. This is also in our documentation, which I'll have a link to at the end. And here I'm using the Amazon command line interface to copy this to my instance here. So when I do that, see, it copies very quickly, and I now have this SRA aligned reads files here. And once you have that, you can interact with it using the toolkit as you would a normal run. So if you wanted to dump FASTQ, you can do that. Here, I'm just going to dump the first 5 reads standard out so that it will be more easily seen. So you can dump FASTQ if you want, get the raw reads out and do your own alignment or analysis there. As you can see, it has placeholder quality scores because the qualities have been removed from these read-align objects. But if what you really care about are the FASTA contigs, which I said previously, some of which represent a new sequence, these aren't samples that are in GenBank, you can get just that out. And so you can use the dump ref FASTA tool to dump just the contigs from these objects. And I'll dump this to just a file here. The dump is quite fast. And if we look at the top of this file, you can see we have the contig name here along with the FASTA sequence of the contig. And they're all in there. So if we just grep for all of the contig names, we got the entire set of contigs from this run in one single file. And if what you prefer instead is to look at the aligned read information, you can use samdump to dump that out, and this dumps to standard out by default. So you can see in the header, all of the references the assembly references are contigs, and here you've got the reads aligned to those contigs. So you can, if you want to visualize where those reads align to the contigs, you can do that as well. And if you want the reads in FASTA, you can do that too. So you can interact with these with the toolkit just like you would any other object in SRA, but you get these extra contigs which aren't really represented anywhere else, and which I think will be of interest to a lot of people. They're designed to be small and fast to work with, give you access to the underlying reads and the assembled contigs in whatever format makes the most sense for your pipeline. And the Athena add-on allows you to narrow your search to specific data of interest before you ever need to download or dump the data. So you don't need to download, dump, align the data yourself, and then see if there happens to be anything of interest there. That's already been done. So you can use the blast results or the contig results to confirm that the data is of interest to you immediately, that it has taxonomy hits that you're interested in, and then just pull those runs that you know have useful information and start analyzing from there. So the queries are also included here in the presentation, and that's available for download. A quick note on cost. This is the predicted cost of today's examples in Athena. So the original, the first query I did, which was contigs by length, cost less than a penny. The other two, the geographic location count and the top blast hits, were both a little under 10 cents. These are the costs based on current Amazon pricing that could change at some point in the future. But as you can see, it's pretty easy and cheap to get started, just get your feet wet here. So if this is something you're interested in, I'd certainly encourage you to do that. Which leads me to feedback is welcome. We really rely on our users to help us improve these resources. So please check out SRA in the cloud, check out Athena. It's pretty easy to get started with. Let us know what you think. If there are problems you have or things we can make better, let us know that. Let us know what other features you'd like in the future. We plan to continue development of this, and we really rely on user feedback to know what would be most useful to the scientific community and what would help you. And if you have suggestions, you can use this suggest at NCBI address to send that information to us. And then finally, a couple quick URLs at the end. The first URL is to our SRA cloud documentation. This has the S3 addresses for all of the Athena data, all the S3 data that you can search in Athena that I showed here today. It also has further documentation on Athena. It has definitions for all of the tables and fields. So if there's a table or field that you're not sure what it is, it's defined there and you can take a look at that. And there's also information on like the taxonomy analysis tool and that kind of stuff if you want to look at that. I've got a link here to Amazon's Athena documentation on saving your query results. It's a little more complete than what I was able to show today because they've got a few ways of doing that. And finally, here's our Getting Started playlist for SRA on the cloud and YouTube. And that's got that video I mentioned about how to set up an EC2 instance and get started with the toolkit really quickly, as well as a few other things that might be useful if you're new to this. And then finally, we've got just the NCBI general help email address and the SRA help email address. So if you're trying to work on this and you're having trouble querying the tables, you can write to SRA and we'll be happy to give you some assistance with that. And with that, I'll say thank you very much for your attention, and I'll be happy to take any questions that you might have.
Thank you, John. There are some questions.
Go for it.
Okay, so the first question, although it's not completely clear what this person is asking, but basically I think they want to know is the GIS AID accessions, are those available or are they mapped over to some of the data that's in the SRA in the cloud?
I am not sure about that. I mean, so here in Athena, you mean?
The person who asked that question, if they can clarify exactly what they want to know, that I mean, part of the question is whether we have all that data at all, which is the GIS AID is that flu resources that collecting the SARS-CoV-2 data.
Right. But yeah, it's not available in the Athena tables currently. It may be available locally at NCBI. I'm not 100% sure about that, but we can certainly get an answer for that.
We can get an answer for that question. Yeah. Another question for nanopore sequencing reads: is the raw instrument output data available?
Yes. So the raw output of data is available for nanopore sequencing reads. That is distinct from like the SRA aligned reads I was showing here today, but we do provide the raw, assuming it was submitted with the raw reads. Sometimes people submit nanopore as FASTQ or something, and in those cases we don't have it. But if the raw nanopore data is submitted, it should be available from the cloud.
Okay, thank you. And this question is good because it follows on to something you just said about the YouTube channel. So somebody was asking, was there an equivalent webinar for using BigQuery and GCP? And the answer is yes, there was that, and that webinar is available in the YouTube channel. The only difference, I think, is that doesn't talk about the read-align objects that you were talking about today.
That's right. That just covers total SRA metadata. That's all that was available then. So it doesn't cover like the read-align objects or the metadata about those, like the blast results and the contig information.
But are they also available on GCP?
They are.
Okay. Okay, and this is a question that I am often confused about, and it's about egress charges. So the question is, for the SRA public data sets on AWS or GCP, are there data egress charges if you want to download your SRA query results for offline analysis?
So for the data that's in the Open Data Registry, so that's the COVID-related stuff that I just talked about, which includes the new aligned reads, there is no egress charge for that. That's provided free of charge. However, for most, but I guess not all of other SRA data that's on the cloud, there is an egress charge usually. So if you just want some other run that's in the cloud and you want to download it from the cloud to local storage for some reason, that would have an egress charge.
Okay, thanks, Jonathan. Another question is, are you aware of any client software that offers a higher level of abstraction? In other words, I think they're looking for something that's that will look at either AWS or Athena or GCP in a platform independent manner. Does that make sense?
So you mean to query this data using some other?
Yeah, so that it wouldn't be dependent on, so for AWS you have Athena, and for GCP you have, the BigQuery stuff. Is there something that sort of works across the platforms? I think that's the question.
For querying, I mean, probably. I'm not aware of one offhand, I guess. I mean, so I will say, so for instance, the data we have stored in S3, I mean, it's formatted, it's in Parquet format, it's designed to be efficiently queried by Athena. We also offer it in JSON if that's something you want. So I mean, I'm sure there is a way that you could query that independently if you wanted to, but it's not particularly designed for that. It's the stuff in Athena has actually been tweaked to be efficient and quickly searched in Athena.
Okay, and this question, and I'm not sure, I don't understand what this is, so we can see if it's relevant to today's webinar or not. So the question is, it's not related to Athena. I just wanted to ask you, do you know which database the PA-NV scores can be found? I don't know what PA-NV scores are. Do you?
I don't think I do know what that is.
Okay. Well, that's all the questions that we have that are directly related to the webinar today. So thanks, everybody. I'm going to go ahead and end the webinar for everybody. Thanks for coming.